So we will be discussing few questions based on the concept that we learned. Like here we are given a hard disk with 20 recording surfaces and 20,000 cylinders, and another data is given that each track is having 80 sectors. Data in disk are organized cylinder wise, and the addressing format is the same thing which we discussed before. Now a file in the disk is stored starting from the address. This is the address from where the storage of this file has started. Now we have to find out the sector number of the first sector of the file in the disk. So we will note down what we need is the number of sectors per cylinder. The number of sectors per cylinder. We know that this is a track, and when we combine multiple tracks, we form a cylinder like this. We are already given this data, which is 80 sectors per track. Means one track is having 80 sectors, and we know that one surface is having multiple tracks, but in order to form a cylinder we need to consider only tracks of same radius, and we know that we are having 20 surfaces. This is 1 2 3 4, likewise we will go up to 20. So we will be having 80 into 20, this is 1600. In a similar way we will find the numbers of sectors per tracks, which is directly given as 80. Now the address is 913 and 36. We have to find the sector number of the first sector of the file in the disk. So for example, a file takes certain amount of storage space, and we start from this position and end up having stored this data up to this position. We'll only need to find out this first sector, the number of the first sector. So firstly we will decode this address to raw number known as sector number. So the formula that we refer to is, we'll multiply this number 900 by the sectors per cylinder, which was 1600. Now this second part 13 into 80, and we'll keep this 36 as it is. This will give us the sector number. This is 1441076. Now we have another question in which there is another hard disk given with 16 recording surface having 10,000 cylinders, and each track contains 60 sectors. The data in the disk are organized cylinder wise. The addressing format is again same. A file in the disk is stored starting from address. This is the starting address, and file is stored on 12563 sectors in contiguous manner. Now what this line says is that, for example, we need two spaces to store one file, and for example this is the space where we are keeping all the data regarding this file. Let's say this has a sector number of 502, 503, 504, 505. So we will need two spaces. We'll use this space and this space. So the starting number was this and the ending number was this. So we used these two places to store this whole file. So this was an hypothetical case. So instead of 502, we will use the sector number, which we will decode from this address. This is the address format which we are given. From here we will take out all the data given in the question, and along with that we'll get sector number. Now this sector number is the starting sector number from where we'll start to store this file. Now this file will take these amount of sectors. We'll let's consider this as x. We'll add this 2563 and remove 1 from this. We'll get the final answer, like the last sector number of this file. So let's proceed. So we'll find out the number of sectors per cylinder. This will be 16 into 60, this is 960, and also the number of sectors per track, this will be 60. Now for sector number, what we'll do is use this 540 multiply with this 960, and then 8 multiply it with 60, and for 12 we'll do nothing because this is the sector number in raw format. Now this will come out to be 518892. so as I said, this is the x which we have assumed first. So we have got the answer 518892. Like if this is the storage space and this first number first sector number is 158892, we will keep putting on the data likewise, and it will take storage spaces of 12563. We'll assume that it will take 12563 boxes, and we have to find the last box number like this. So the sector number of last sector of file, that will be 518892 plus 12563 minus 1, which will be 531454. This is the ending sector number for this file. Now we again have this question in which we are given similar kind of data: 18 recording surface, 10,000 cylinders, and each track contains 64 sectors. Data are organized in cylinder wise. The address format is same. File disk is the starting address is this, and the file is stored on these sectors. This is the amount of sectors required to store this file. This is stored in contiguous manner, and the question has asked us to find the address of the last sector of the file. Like in the previous question, we have to decode this address. We get the raw sector number, means the box number from which we have started storing this file, which is of 6563 sectors, and we have to find the last sector number only. But in this case we will get the last sector number and then again convert it back into this kind of format, CHS. These are the notations. This represents cylinder number, this represents sector number, and this is simply this is surface number, and this is sector number. So we'll proceed like this: number of sectors per cylinder, which will be 18 into 64. 18 is the number of recording surfaces, and there are 64 sectors on each track, which will be 1152, and the number of sectors per track is 64, directly given in the question. Now the starting sector number will use this address format given in the question to decode this into the raw sector number. So we'll use 248, multiply it with 1152, then we have 11, multiply it with 64, and keep 51 as it is. We'll be getting 286451. Now ending sector number, we'll use this first sector number, then add the number of sectors required to store this file, and then we'll remove one space because we have started storing it from the first stage itself, which will be 293013. This is the sector number we have got. Now when we need C, the address format was CHS. So for C we need this 293013. We'll divide it by 1152, which was this number of sectors per cylinder. We'll take the lower bound, which will come out to be 254. Now for the surface number, we'll again take the lower bound of this, but this time we'll be doing modulus. Why? To get the remainder, and now we'll divide it by number of sectors per track, which is 64. this will be 405. We'll get 405 as remainder, and 64, this will be 6. And for the surface number, we'll do the same thing, but instead of this divide, we'll be using modulus. So the final answer will be 21. So the question has asked us to find out the address of the last sector of the file. So this was the sector number, and we have converted it into this format. We have all these data, we'll put into it, and the final address will be 254,6,21. This is the cylinder number, this is the surface number, and this is the sector number. The sector, surface, cylinder.